Cambridge, Mass. to speak with MIT professor David Newman. Her team is designing a new type of spacesuit that's going to be super effective and way comfortable for our astronauts. Hey, another great thing about this suit, might have some benefits for people back here on Earth. We're here at the Manned Vehicle Lab at MIT with Dr. David Newman. Doctor, thank you for coming on the show.
Thanks, Johnny. It's a pleasure to be here.
Thanks. So tell me a little about what you guys are doing here.
So we specialize in looking at astronaut performance for both microgravity, the moon, Mars. We'll be able to talk to you today about some of our work in advanced spacesuit design. We're trying to design a suit actually to get astronauts to Mars. So it's a pretty futuristic looking concept. We call it the biosuit. We call it a second skin. You have to apply pressure to keep the astronauts alive. So in the current suit, that's like a balloon. You're operating inside a balloon. It's called the extravehicular mobility unit. Very massive suit, very heavy. It's about 140 kilos now. Now we're in Space Shuttle or on the International Space Station. It's weightlessness. So the astronauts don't feel the mass of the suit. They can work in it. It's great to do Hubble Space Telescope repairs. But when we get to the moon and Mars, we need a locomotion suit. So a lot of our research is geared to how do we provide astronauts with maximum mobility and minimum energy requirements. We want them to be able to go out and be productive and work for a long time. So that's what you'll see in the biosuit. The huge advantages are then we can aim for maximum mobility. It's much more like wearing clothes than it is operating in a big gas pressurized shell. Some of the advantages we have for the biosuit is we can have a really lightweight suit. When we get to the moon and Mars, our astronauts are going to be kneeling down and climbing and doing some really extreme tests. So we need to provide maximum mobility. And then finally, safety reasons. If, let's say you get a little tear, you're working on your knees and you get a little tear in the suit, we envision then you just put another layer on. You just wrap it up. Another layer of mechanical counterpressure. You just keep doing your business. You keep doing the science and experiments.
So you can repair the suit, I mean,
we think so. It depends. If we can get, millimeter by millimeter, kind of small rip. You can't have a big gaping rip, of course. You have to always pressurize the astronaut explorer. But for a scuff or just a scratch, we think we could just put a quick bandage on it, literally. So some of the design concepts that we've incorporated into this mock-up, the black lines that you see are something we call lines of non-extension. If you move your skin and your arm and you move around, we want to again get maximum mobility. So it turns out if we have to carry the pressure, again you want to pressurize the person and attain maximum mobility. So the black lines have a lot to do with trying to achieve that, holding a constant pressure while providing maximum mobility. The gold lines that you see all over the suit, they kind of follow major muscle groups for thermal control to make sure that you're providing enough heat. And so you would just weave that in. The idea is you just weave that in and get thermal control, would sense the astronaut's temperature and heat them up if necessary or perhaps cool them down.
So how does it help astronauts on other planets?
So you can imagine if we can put here in the knee joint something that helps someone walk. When the astronauts get to Mars, they might have gone through a lot of physiological deconditioning. So you might have to assist their locomotion, probably in the first month until they really regain their muscle strength back. They might have a loss of about 40% muscle strength loss, 20 to 30% muscle atrophy. So if we can give them some assisted locomotion, that will really help, say, on early arrival to planets. It's a very expensive mission. We want to send people there, but when you get there, you can't take a month off. You need to work almost immediately. So we need to hopefully embed some of these enhancements, technological enhancements, kind of where the human and the robot come together in future suits. One of our 1G and medical benefits of some of our research are to think about helping people with disease on Earth. For instance, like locomotion. We really like to help people walk. We think about how our astronauts are going to walk on the moon and Mars, but there's a lot of people here, of course, on Earth that we'd like to help. So we look at some disabilities for stroke, cerebral palsy, multiple sclerosis, and we think of assisting that locomotion. So our designs help in that sense. We've had one project that's assisted locomotion, basically putting a power assist on a leg. For instance, a stroke patient usually is affected asymmetrical. So you might have the right side of your body that's working well, but for locomotion, your left side might not work so well. So we can take a look at the left leg then and try to give it a bit of a kick, if you will, to help the locomotion. You can take signals from the right side of the leg that's working perfectly and get the same ankle, knee angle, instantaneously get those to the left leg and then have the right and left legs work together. Other applications for 1G that are kind of for extreme sports or athletics, you can imagine helping people maybe jump higher, run faster, things like that. So that's where some of our robotics technology kind of embedded into some of these designs for the future. We'd like to pursue some of that research. This is our latest biosuit mock-up.
Cool.
We've worked with businesses here in the U.S., Charlie & Associates, and with some Italian designers, Dainese. It is skin tight. This is just a mock-up that kind of has the look and the feel of what the skin suit might look like in the future. So I can kind of demonstrate the mobility. It's really easy to bend down. I probably spend a lot of time, doing research.
Sure.
And the Moon and Mars in these kind of configurations. And the trick to mechanical counterpressure is if we put it on and it's pretty comfortable, then we want the ability to, while it's on, to be able to kind of cinch it up, get that final pressure production.
That's right there.
Right, so we can kind of show you a little demonstration. This is just a little mechanical system we're thinking about, but you can kind of see it cinching up, and sure enough, if I get it really tight here, it kind of applies more pressure.
Is it comfortable?
It's really comfortable.
Yeah?
Yeah.
great.
Nice and warm. It's nice and warm. I can show you with the helmet on. People don't think it looks like a spacesuit until you put the helmet on.
Ah, cool.
All right, put that on. You need gold sunglasses in space.
Where'd you go?
There you go.
Something else.